All right, folks, we're going to get back at it here, and we are rounding third and heading to home in our section 10.4 example problems. The example we're doing here will relate back to web assigned question 20 through 22, and it is use of the product to sum formula. And if we go back to our reference sheet, second side, we will see the product to sum formulas there about the middle of the back side of that reference sheet, and you'll notice that these are not formulas you have to memorize. Should you need to use these, they'll be provided for you. So let's take a look at this. Product to sum, what does that mean? Well, this currently is written as a product. It's cosine of 3 theta times cosine of 5 theta. That's the product part. What we want to do is transform it so that it's a sum, and we will use the product to sum formula for the cosine of alpha times the cosine of beta. And you can see my dogs are really excited about this, converting a product to a sum. So I'm going to try to calm them down and we'll get back at it. Okay, order's been restored. Let's continue. So the cosine alpha, cosine beta, product to sum formula looks like this. And again, here is there's the product part of it, and then there's the sum part of it. So we're turning a product into a sum. And I'm going to go ahead and run through this now. Okay, here's I want to pause here to just comment on one thing. Let's take a look at this cosine of negative 2 theta. I want to go back real quick and just look at some of our even odd identities that we had in our reference page. So the cosine of negative theta is just equal to the cosine of theta. So I can go back here and make the following statement. Cosine of negative 2 theta equals the cosine of 2 theta, and that's from our even odd identities. So let's continue. And that's it, folks. That's as far as we can simplify this problem. The cosine 3 theta times cosine 5 theta is 1/2 times the sum of cosine 2 theta and cosine 8 theta. So that's it for this example. I want to caution you, and some students may try to simplify this further by saying, oh, I have a formula for cosine alpha plus beta. That formula you can't apply here, okay? So the cosine of 2 theta plus 8 theta does not equal cosine of 2 theta plus cosine of 8 theta. And that's one of those things where students make that mistake. I just want to make sure you're not looking at this as, oh, I can use a sum difference formula and take this a little bit further. That's not the case. All right, that's great. Now I have to admit that I've been lying to you for the past 4 videos. I said we had 10 example problems. I lied. There's 11. And so we're going to look at 10 and 11 now. They're very similar. These will relate back to web assigned questions 23 through 28, and we're using the sum to product formula. And I want to give you a hint about something, a little foreshadowing for the future. Sum to product formulas, well, we're going to take either a sum or a difference and turn it into a product. And how might this be useful to us in the future? Well, think about this. A product, if we have an equation, we might be able to use the zero product property, which I'm going to run out of space there, so let me property. The zero product property is, if you've been listening to me at all this year, that's what I think is one of the most underrated tools in all of algebra. So when we get to the next couple sections and we start solving equations involving these trig functions, the zero product property is going to be really helpful to us. So that's where this formula, the sum to product formula, might come in handy in the future. So let's start with number 10 here. Number 10 is sine 2 theta minus sine 7 theta. And the first thing I'm going to do is write down that sum to product formula for us. There it is, folks. That's the sum to product formula. Now let's apply it to sine of 2 theta minus sine of 7 theta. At this point, folks, you might be like, well, there's nothing else I can do with this problem, but I want to remind you that we do have some even-odd identities. And there's one that will help us here. Identity. There's one that's going to help us with this. The sine of negative 5 theta over 2 is equal to the opposite of the sine of 5 theta over 2. And that's back again from our reference page. We look at the even-odd identities on the front side there, and we have this. We have the sine of negative theta equals the negative sine of theta. So we're going to use that here to make this a little simpler and see where that gets us. And there you have it, folks. We have simplified the difference sine 2 theta minus 7 sine theta into a product. We've turned that into a product. And again, I want to remind you that when we get to solving equations involving these types of trig functions, this is going to come in handy using the zero product property, because once I have a product and I know that it equals 0, I can set either term equal to 0 and find out a solution to that equation. All right, let's move on to number 11 here. Now, number 11 is a little tricky, so it's going to require a little bit more space here. So I'm going to scroll down and say that number 11 was sine of theta minus cosine of theta. And this one, it's going to be a little bit tricky. So folks, I have a hint for you on this one. We don't have a sine theta minus cosine theta formula. So what do I mean by that? If I go back to our example, or our notes here, right here, I'm looking for all of my sum to product formulas. Here they are. And you'll notice I have cosine plus cosine, cosine minus cosine, and then sine plus sine or sine minus sine. I don't have any that mix sine and cosine together. So because I don't have a sine minus cosine, I'm going to use a cofunction identity to turn it into cosine minus cosine. Well, what the heck do I mean by that? Remember this, that the sine of theta is equal to the cosine of pi over 2 minus theta. That's a cofunction identity. And I'm going to use that to rewrite this in terms of a cosine minus a cosine. It's going to look like this. So I rewrite this problem as cosine of pi over 2 minus theta minus cosine theta. And from there, I can use my sum to product identity for cosine and see how this simplifies. There you have it, folks. Kind of crazy, but the sine of theta minus the cosine of theta simplifies to negative root 2 times the sine of pi over 4 minus theta. And that's it for our example problem. So thanks for sticking with me through this 5-part video series on trigonometric identities and examples.